Alright guys, I'm just going to do a bit of an update on all the development work I've been doing for the BotBitz stuff. So what I've been working on recently is a programming box for our speed controllers. So we have this is a programming box from Wiki, and this has been reprogrammed to basically allow you to set all the settings on our speed controllers. So these are my two dev units I've got behind me here. As you can see, it's been opened up and programming cable attached. And here is a 85 amp ESC with its case off and wires attached to it as well. So I'm just going to run through a few of the things that we can do with this. So first of all, this is what it looks like. You've got 4 buttons, you've got menu, plus, minus, and enter. So with the new firmware I've developed for our speed controllers, there's a number of settings which you can set. This includes the endpoints for your radio controller, the deadband in the center, the amount of buffer that you have when the controller will max out, other things like the slew rate, so how fast the speed can change, voltage limits, temperature limits. So first of all, if you want to set your RC limits, you need to know what they are. So the first thing I did when I made this was add in a mode. So if you plug the programming box in to a receiver, so if we power the receiver from this 8.8, see the light comes on, we get power to our BotBitz controller here, and if it starts up and doesn't detect an ESC, it goes into basically a wait mode, waiting for an ESC to come about. If it doesn't find one in 5 seconds, it then displays a message saying unknown ESC. There's no ESC connected, so what it does is it starts looking for pulses. So if I turn on this radio here, we have the pulse length displayed. So in the center it's 1.49 or 50, and then if I turn the knob here, you can see that it changes. If I pull the trigger, you can see it goes up to 2 and down to about 1. That's a handy little feature for working out what the actual center points is and what the endpoints are for your receiver. So the next thing I want to show you is what happens when you actually connect to the speed controller. So how this works is you plug in the lead from the speed controller with the BEC enabled into here. What you then need to do is you need to power cycle the speed controller. So if it's turned off, you just plug it in. If it's already on, you need to power cycle it. And then this will detect what type of speed controller is connected to the box, and then it goes through the settings. So the first one here is a low limit, so complete reverse. And this is set to 1 millisecond on the controller. So if we want to change this, we just go up and down, and this will update on the right here, and then this is the current value stored on the speed controller. So we want it, let's say we want the lower limit to be 1.05 milliseconds. If I then press enter, it's then stored on the speed controller. And just to show this, I'll just power cycle the speed controller. So it detects 85 amp, and then when it powers back on, it's stored in the speed controller. So this lets you set up all of your limits based on your transmitter. So if we run through, the next one is the midpoint, so basically the center point, high limit, same as low, except the opposite. Then we get into other settings, such as the deadband. So this is the amount in the center. So the next is the RC buffer. So this is how far you can go over the top limit. So if you have the top limit set to 2 milliseconds, you can go up to 2.2 milliseconds, and this won't actually throw the speed controller into failsafe. So you can lower these limits based on what you think you're going to see from your transmitter. The next is startup beep. So I configure these speed controllers to beep when they start up, so it does 3 beeps when you plug it in. You can turn this on and off based on whether you like it or whether you don't. So this is set to 1, so 1 is on, 0 is off. So let's just turn that off. So the other thing is a reverse. So if you've ever soldered up your whole robot, plugged in your speed controller, and then found out that your mixing is incorrect, it's much easier to just switch the wires on the motors than it is to actually reprogram your radio most of the time. So what you can do is you can just plug this in, change 1 to 0, and that will actually reverse it in software. So you don't need to go resoldering wires. Slew rate. Slew rate is how fast the speed controller swings from high to low. So this is set at 8, which is basically the stock one. If you lower it, it will take longer to change from slow speed to a fast speed. This basically means it's easier on your speed controller because you get less peaks in your transient current. If you make it higher, you'll get a slightly faster response, but it is more harsh on the speed controller. Voltage limit. So this is another feature I've added. So this is what voltage the ESC will cut on. So if you have LiPos and you don't want to run them below, say, 3 volts, you can set up this to cut the ESC when it gets to that voltage. Default is 0.7. That is basically 0. The ESC will never cut out as long as it's got enough power to run. It needs about 6 volts to run, so this is not an issue. Temperature limit. So in the past I have had temperature limiting on these controllers. One of the issues that I have with temperature limiting is making it settable. It varies from controller to controller just based on the variable resistor, and it's never really the same, so you need to tune this based on your application. What will happen is the value read from the ADC will drop as it gets hotter, so you can set a cutout value. Basically, I don't know the mapping in temperature from this, but I can tell you as a rule of thumb, room temperature is about 190, and a very conservative cutout point is about 170. Really, I have not tweaked this. I haven't done a lot of work on this. You need to work out what the appropriate value is yourself. This is just in case you want to use it. Serial ID. So it's an interesting one. So the other thing I've added to these controllers is the ability to run them off an Arduino. So I wanted to make it so that you could send a ID to the controller and then a motor speed, and you could run up to, I don't know, 10, 20, 30 controllers off a single Arduino with one wire. So this motor's been set up for the ID 10, and I'll demonstrate that in a minute. Last of all, we have reset order settings. So yeah, and that's basically the control blocks. So you can just go through, set all these to whatever you want, and away you go. So the last thing I was going to show was the Arduino running radio speed controller. So if I connect up the speed controller here, and the power's on. Note that I just turned off the beep, so it didn't beep when I plugged it in. I'm also going to hook this scope to the RC line, so we can see the signals. And then I'm going to plug in this Arduino. This Arduino sends the motor ID, which is 10, if you saw that before. It then sends a 16-bit number, so from 1000 to 2000, with that being basically the time in milliseconds, the same as the time in milliseconds, so 1000 is complete reverse and 2000 is completely forward, and then the center is 1500. So if we were to plug this in, see this LED as it starts up, and then the Arduino starts sending commands. So here we have the serial packets which are being sent from the Arduino over the ESC. And you can drive 10, 20 motors off this if you really wanted to. It just depends on the frequency that you can update them at. So yeah, so exciting new things that I've added on. Still might be more things added later, but that's what I have for the moment.